Dear students, let us see how to find out application on these three situations. Two masses are connected with the help of a string. The string is massless and the string is inextensible also. The pulley is massless, so pulley is also massless, right? Now in all these three situations, using Newton's second law of motion, we have to find out the acceleration of the objects, different blocks, and second we'll find out the tension involved in the string. Now in first case, when you see the first case, you will observe that the two forces on these blocks, on this block is subjected to force. If you draw the free body diagram, let us take M1G, we are representing the forces on the free body diagram, and tension will be acting in upward direction here, right? Is it? Now here you will see the weight is acting in this direction for M2G, and then is acting in this direction, upward direction. Now you will observe that the block M1 will come down only when M1G is greater than M2G, because two forces are there. M1G is in downward direction, M2G is also in downward direction. Now if M1 moves in this direction, then obviously this force will be greater than this force, then only it will come down. So we can write down M1G minus TE equals to mass into acceleration A0. If it is moving in this direction with acceleration A0, I can say Newton's second law, this is the net force on M1, M1G minus T equals to M1 into A0, right? Similarly, if it comes down, then this block will go up with acceleration A0. I can say in second block, the T minus M2G is M2A0. So when you add these two, you will observe T will get cancelled. You will observe M1G minus M2G equals to M1 plus M2 A0, or acceleration can be written as M1 G minus, or I can take G common, M1 minus M2 G divided by M1 plus M2. And once you know the acceleration, you can find out T from this expression. I can write T equals to M1 G minus A0. Place the value of A0 here, get the value of tension. I think I can find out this tension as M1. Let us take G minus A0 is M1 minus M2 by M1 plus M2. I can take this G also common, so let us take G out and I can write 1. So when I take M1 plus M2 here minus M1 plus M2, you get 2M2, so this will become 2M1 M2 G by M1 plus M2 is the tension. If you solve this value, M1 plus M2 minus M1 plus M2, 2M2 I will get 2M1G, M1G, 2M1M2, M1 plus M2. Is it clear? Right? Now, this problem, this is the fundamental process to solve the problem. But if you are not having so much time to write down so many things, now you can directly find out the net force on this. To decide the acceleration of these blocks, you can take the net force. What is net force? Net force are causing the motion. So once you find out this net force on the system, I can say the net acceleration of the system will be net force divided by total mass of the system. So if you observe here, since two forces are there, M1G, M2G, so I can write down in first case the net force will be equal to, suppose M1 is G minus M2G. Now acceleration will be given as that net force by total mass M1 plus M2, and I can write M1G minus M2G by M1 plus M2. Directly you can write down the acceleration. And once you know the acceleration, you draw the free body diagram, get the value of t, that will be equal to 2 m1 into g by m1 plus m2. Now in this example, I will not go so lengthy process. I will directly find out acceleration here. Now let us see this example. Two blocks are there on right side, M3 is on left side. We have to find out the acceleration. I told you we find out the net force acting on the system. Now the net force on this system will be, you just see, M1G will be in this direction and M2G will be also in downward direction. So right side you will observe two forces are in downward direction, M1G plus M2G, and this one is downward direction on left side, M3. So I can say the net force is nothing but it is M1 plus M2 minus M3G is the net force. Is it clear? Suppose M1, this is coming down with acceleration A0, let us say. So I can say the net force here is M1 plus M2 G minus M3G is the net force. So I can write down this acceleration as A as net force by total mass of the system, that is M1 plus M2 plus M3, and this acceleration can be written as M1 plus M2 minus M3 G by M1 plus M2 plus M3. Very easily you can find out the acceleration, and once you know the acceleration, you can decide what is this tension T1, what is this tension T2. There will be in this string T2 will act, in this string T1 will act. So just drawing the free body diagram of this one, we can find out what is tension T, how M1G minus T1 will be M1 into A0, right? And for T2, M3G, T2 minus M3G is M3 into A0 in vertical direction, upward direction. So you can find out T2 also. Now here, in case 3, you will order what will be net force, what is the net force driving the, giving the acceleration in the, third system. Now third system, the net force is only M1G here. You see, M1G. And this M2G is acting on the table. So this will be balanced by the normal reaction. Is it? Tension will be acting here, T, and this T, friction is 0, so friction force will be 0. This will be the situation. Now here the net force is only M1G. So I can write down the acceleration in third case, A0, net force by total mass is M1 plus M2. Now net force is how much? M1G. So I can write down M1G by M1 plus M2. And once you know, I can write down the tension as M1G minus T is M1 into A0. And so T will be M1 G1 minus M1 by M1 plus M2. Right. Now M1 gets cancelled, so you get T as M1 M2 by M1 plus M2 G. So in these three situations, once you learn the concept of net force, you can very easily decide the acceleration of the system within fraction of second. So this practice should be developed to solve the problems, because this will save you time. So net force concept is very important. I will tell you other examples also. So many examples are there where you can learn the net force, how to find out the net force. So let us see in next class. Thank you.